So, hello friends. Today we are going to see the next part of our continuous learning of technical general. The first question is: oil is used in an oleo strut. Oil is used in an oleo strut to, what is the option out of these four? Is the answer D is the correct, to limit the speed of extension and compression of the strut. This is the answer. See, pneumatic struts. Our landing gear is made up of landing gear is made up of pneumatic strut. So this is the top part. This is the axle lower part where the wheels are installed. These are lower cylinder, gas is filled. This is upper cylinder, fluid is filled. So the oil is used in the oleo strut to limit the speed of extension and compression of the strut. Otherwise, the speed will be very fast, and that is going to damage in case of extreme or heavy landings. Nose wheel centering. The nose wheel assembly must be centered before retraction because, see, we have three bays: bay 1, bay 2, bay 3. Here, the landing gear is extended like this. The wheel. The wheel, it should be centered like this, in alignment with the axis of landing gear nose. It should be centered because there is a limited space in the nose wheel bay. The tire should be centered. It cannot come like this because the nose bay is of limited width, and if it goes like this, then it is going to damage the nose wheel bay. Damage the wheel bay, nose wheel bay. See, why nose wheel centering is happening? Nose wheel centering is happening to avoid damage to the airframe structure. The nose wheel must always be aligned in a front and aft direction during retraction, and a number of methods are used to ensure that this happens automatically. ठीक है. Hydraulic nose wheel centering on aircraft is done with power steering. Third, the movement of gear on lowering is normally dampened. Why? See, the movement of the of the landing gear on lowering is normally dampened to prevent the hydraulic fluid becoming overheated. If it is not dampened, then the hydraulic fluid will become overheated. inadvertent retraction of the landing gear on the ground. Suppose the landing gear switch on ground, someone puts it up or orders it for retraction. So inadvertent retraction of the landing gear on the ground is prevented by the ground air logic system. Is prevented by the ground air logic system. See, what is the gear selector lock doing to prevent inadvertent retraction of the landing gear when the aircraft is resting on its wheels? A safe device is incorporated which prevents movement of the selector lever. The lever will not go up. This safely device consists of a spring-loaded plunger which retrains the selector in the down position and is released by the operation of a solenoid. It means if we want to go up gear selector lock, then it will not go up because it is not energized by a solenoid. Electrical power to the solenoid is controlled by a switch mounted on the shock absorber strut, part of the air ground logic circuits. When the strut is compressed, the switch is open, but as the strut extends after takeoff, the switch contacts close and the electrical supply to the solenoid is completed, thus releasing the selector lever lock and allowing the landing gear to be selected up. A means of overriding the lock, such as separate gated switch to the complete the circuit or a mechanical means of avoiding the locking plunger is provided for emergency use and for maintenance purpose. Creep, slippage. What is a creep or slippage? Creep is the alignment can rip the inflation valve on tube tires and deflate the tire. The slippage. Alignment can rip out the inflation valve on tube tire and deflate the tire. So 5C is the correct answer. This, with the increased size of modern airports, taxi distances also increase, thus increasing the amount of tire wear and risk of damage. To minimize tire wear, therefore, it is recommended that a speed of no more than 40 km per hour, 25 miles per hour, should be reached during taxiing. So, tire wear when taxiing can be reduced by, we know that tire wear when taxiing can be reduced by taxiing at less than 40 km per hour. So 6B is the correct answer. To prevent scrubbing the tires while taxiing, you should C. Turn no sharper than minimum specified radius. Because if you turn radius is this and if you turn like this is the minimum radius defined, and if you turn like this, then the scrubbing of the tires happens. See, the best fire extinguishant to use on wheel on brake or brake fire is, see, whenever brake fire happens, whenever it happens, the best extinguishant to use on wheel or brake fire is B. Dry powder. Dry powder is being used to extinguish the fire on the wheel and brake. When inflating a tire fitted to an aircraft, the tire pressure reading on the gauge should be modified by 4%. D is the correct answer. When inflating a tire fitted to an aircraft, the tire pressure reading on the gauge should be modified by 4%. So D is the correct answer. The most likely cause of brake fade is C. Recent technological advancements in heat dissipation have resulted in the design of the brake plates being changed from a continuous rotating single plate to a plate constructed of many interconnected individual segments with the heat dissipation properties greatly improved, thus increasing brake efficiency. Carbon is also used for manufacturing brake units because it has much better heat absorbing and dissipating properties. Carbon brakes are also much lighter than equivalent. Carbon brakes are also much lighter than equivalent steel units. The disadvantage is their increased cost and shorter life. So they tend to be fitted only to aircraft where the weight saving is worth the extra cost. Long haul aircraft, for example, if the brakes become too hot, they will not be able to absorb any further energy and their ability to retard, slow down the aircraft diminishes. This phenomenon is termed brake fade. So, the most likely cause of brake fade is D, the brake pads overheating. That's all for today. Thank you.